recursive, explicit, recursive, and explicit. Maybe you want to just label them. I won't label them for you. I will just give you this. But here's your setup, right? You have on the left, are those the arithmetic or the geometric on the left? Sorry. Yes, that's arithmetic. What's up, Jada? On the right is your geometrics, so 2 of each, okay? And then recursive versus explicit. Which one's the recursive formula? Left or right? The left one, right? This is your recursive. This is your explicit. This is your recursive. And this is your explicit, okay? So try to keep those straight, what is what, but I'm not gonna try to mess you up and switch the order. They will be in that order for you, looking just like that. Those are your formulas. Okay, you ready? You gonna talk to me right now? Let's chat. Okay, so this first one, it says decide whether each formula is recursive or explicit. So just R or E, you're just gonna circle those on the test, an R or an E on the quiz, and find the first 5 terms. Letter A, is it recursive or explicit? That is recursive. Okay, so with a recursive formula, if we're trying to find our first 5 terms, what's our first term? 2, okay, so our first term is gonna be 2. How do you find your second term? A sub 2 is what? What is this? What is A sub n minus 1? You're going to plug in the 2, but which 2? Is it this 2 or is it this 2? It's the first 2, right? You're plugging in the term before the term you're talking about. So A sub n minus 1 is the first term. It's A sub 2 minus 1, which is this 2. So you're kind of plugging in both 2's, I guess you would say. So this is going to be 4 times 2, or 8. So my second term is 8, okay? My third term is 4 times what? Times 8, right? The term before it. 4 times 8 is 32. Okay. My fourth term, A sub 4, is going to be 4 times what? 32, the term before it, right? This term's getting plugged in there, and you get 128. And then it's 4 times 128 is 512. Okay, so your first 5 terms look like that. Make sense? Yeah, Jada. So you are plugging in 1, 2, 3, 4, and 5. But if you did that right here, right? So if I want my third term, A sub 3, that's 4. I won't write it like that. 4 times A sub 3 minus 1. So that's A sub 3 is 4 times A sub 2. Well, what is A sub 2? That's your second term, right? A sub 2, we said, was 8. So you're just taking the term before it and dropping it in. Recursive is always plug in the number for your variable from the term before it. Yeah. Not the term number, the term itself. Like what number you got as your answer is going to get plugged in for your A sub n minus 1. Explicit is always just plugging in the number of the term. Like if it's the first term, you plug in 1. If it's the second term, you plug in 2. If it's the third term, plug in 3. Yeah. Okay. Okay, letter B. Is that explicit or recursive? That's explicit. Okay, recursive will always have a sub 1, right? Recursive always has this first. So it always has 2 pieces to it. Explicit will only ever have 1 piece to it. So if we want the first 5 terms, then it's a sub 1 equals what? What are you plugging in for n right now? 1, right? It's your term number. 1 squared minus 1. So a sub 1 is 1 minus 1, or 0. Okay, that's your first term. A sub 2 is going to be 2 squared minus 1, which is 3. Okay, so your second term is 3. A sub 3 is what?
8.
3 squared minus 1, which is 8. So 0, 3, 8. Your next one, a sub 4, is going to be 4 squared minus 1, so 15. And then a sub 5 is 5 squared minus 1, which is 24. Okay, so those are your first 5 terms. Questions on that? Okay, take a look at these next ones then. It says identify each sequence as arithmetic or geometric. So you're trying to figure out, am I adding something each time or am I multiplying by something each time, right? This is going to be adding, this is going to be multiplying. So 3 to negative 15 to 75 to negative 375 to 1875. What is that? That's geometric. Can you tell me what your common ratio is? Negative 5. If you multiply by a negative 5, you'll get the next term there. So it didn't ask for that, but that would be your R if you were solving a problem with it. What about B? That's arithmetic. And what's your D? What's your common difference? Negative 4. Yeah. Questions on that? Okay. Write an explicit and recursive formula for the arithmetic sequence. Okay, so now here's the deal. I'm telling you it's arithmetic, so you don't have to check for geometric, right? These are arithmetic sequences, so we have a common difference is what we're looking for. That means we're using these equations, right? Okay. So look at that first one. What is your common difference going to be? Do you remember how to check it? Second number minus the first, right? So if you go 2 minus a negative 5, you get 7. If you go 9 minus 2, you get 7. 16 minus 9, you get 7. So we're adding 7 each time. So if we're going to write a recursive formula, what comes first? A sub 1 equals negative 5. And then a sub n equals a sub n minus 1, right? That never changes. It's always going to look like that for the recursive. What do you do from there? Remember, you got this formula up here. So we're doing this right now. A sub n equals a sub n minus 1. What's your plus d? Plus 7, right? We're adding 7 each time. So you're going to go plus 7, and that is your recursive. Your explicit, now we're going to use this formula, okay? So a sub n equals what? What comes first here? Negative 5, a sub 1. Plus, and then it's n minus 1 times that 7. Okay, and now to simplify that, we're just going to distribute. So negative 5 plus 7n minus 7. So you get a sub n equals 7n minus 12. Would be the most simplified version of it. Questions on that? You guys are so expressive this morning. Stop it. Okay, recursive for letter B here. What is a sub 1? 32. Okay, so then a sub n equals a sub n minus 1. What? Minus 2. You're subtracting 2. And remember, 30 minus 32 will get you a negative 2, right? So you're subtracting 2, subtracting 2, subtracting 2. So that's all you got to put there for your recursive. Explicit is going to be a sub n equals your first term, 32, plus n minus 1 times that common difference, times the negative 2. So distribute that. A sub n equals 32 minus 2n plus 2. So a sub n equals a negative 2n plus 34 would be your simplest version of that. Good? Do you need a Jolly Rancher? Need a little bit of sugar in your system? Wake you up a little bit? I can get you a Jolly Rancher. Man, Broadway and a time change was a brutal idea. My sister doesn't have school today. It's the end of their quarter, so they have today off. I was like, that's brilliant. The day after a time change, you should absolutely have the day off, right? Should have. I'll have to recommend that to admin, see what they say. Okay, this one, write a recursive and explicit for the geometric sequence. Again, I'm telling you what type of sequence it is here. So you can look up here and go, oh yeah, that means I'm using these two formulas, okay? So recursive starts with what? The negative 3. A sub 1 is going to be negative 3. And then a sub n equals a sub n minus 1. What's happening there? How am I getting to the next term each time? Yeah, you're multiplying by negative 3. Remember, you can do 9 divided by negative 3, and you'll get that negative 3, okay? Second term divided by first term. Third term divided by second term. Any term divided by the term in front of it will get you that negative 3. So times a negative 3. I'll write it like that so you're not confused like I'm subtracting. So then the explicit formula, ooh, real quick. Make sure this is this negative 3. This is this negative 3, right? I just realized they're both negative 3s. I don't want you confused on which one is which. So for explicit, a sub n equals a sub n minus 1. Oh, I'm doing the wrong formula, you guys. I'm doing the explicit, or the recursive. Explicit formula. A sub n equals what? What comes first with the explicit? The first term, right? The negative 3 times what? Not n minus 1, something to the n minus 1. What number?
R.
Your r, negative 3 to the n minus 1 power. That one looks a little funky. Here's a question for you. Can I multiply those negative 3s right now?
No.
No, why not?
You have to square.
You have to take the exponent first, right? So don't combine this. This is not 9 to the n minus 1 power, okay? You have to leave it just like this because once you plug a number in there, you have to take that power to that second negative 3 before you can multiply by the other negative 3, okay? Okay, is that a hand up? Just a stretch. You're making me tired, Jada. All right, so we have 400, 200, 150, 25. Recursive formula. What comes first? A of 1 is 400, and then a of n equals a sub n minus 1. How do you get from 400 to 200, 200 to 100? Times a half, okay? So again, this number divided by the first number. Second divided by first is 1 over 2, right? 1/2. You may call it 0.5. That doesn't bother me. But you're taking that a sub n minus 1 times 1/2. Okay? For the explicit formula then, we're going to do a sub n equals our first term, the 400, times that common ratio, 1/2, to what power? To the n minus 1. Okay, now question. Is that 200 to the n minus 1 power? No, okay? Have to do the power first. So don't multiply those together. You're going to take it to a power whenever you come up with what your n value is. Okay, these guys. So letter A here, we're going to say this is an arithmetic sequence. How do you find the arithmetic mean?
Plus divide by 2.
Good. 32 plus 74, and then divide by 2, right? Arithmetic is adding with those. So 32 plus 74 divided by 2 comes out to 53. How do you do it if there's 3 blanks in the middle? Find the middle one. Okay, so it's 5 plus 49 divided by 2, and that comes out to 54/27. Okay, and then you can do it 5 and 27 and divide by 2, and you get 32, so 16. And then you can do 27 and 49, add those together, divided by 2. You'll get 76, so 38. Okay, so arithmetic, you add together, divide by 2. Add them, divide by 2, add them, divide by 2. What if it's geometric? Then you square root, and what do you do with the 15 and 540? Multiply them. So 15 times 540, and then square root that, and you get 90. You just plug that into your calculator, right? Okay, last one. And then you'll have 10 minutes. If we're going to find the 52nd term of the sequence, what type of formula are we going to use? Explicit, okay? So we're going to write an explicit formula, because recursive is terrible if you have to do it 52 times. You don't want to do that, I promise. We got to figure out, is this going to be arithmetic or geometric? How do we figure that out? Start here. If I go -7 minus a -10, I get 3. Now go here. -7 and -4. Is 3 the common difference there? Yep. -4 to -1 is 3 the common difference? Yep. What if it didn't work out? What if they weren't the same? What would you try next? Dividing, right? You take -7 divided by -10, -4 divided by -7. You're looking for something to remain constant. Well, the 3 remains constant. So we're adding 3, adding 3, adding 3 all the way through. So that means, if you look back up to the top, which of these 4 formulas are you using? Number 1, number 2, number 3, or number 4?
2.
Number 2. You're using the explicit arithmetic, right? We're adding. And the explicit is the one that's going to get us a 30 or 50-second term quicker. So that means we're saying a sub n equals what? Remember, it's this formula. A sub 1 plus n minus 1 times d. So a sub n equals -10 plus... Now, if you want to right now, you could plug what in here? 52, right? We're trying to find the 52nd term. So you could plug the 52 in right now if you want. If that's going to throw you off down the road for other things, you don't need to. You could just make it an n right now. But you can just plug it in. If you plug that in right now, your common difference is 3. You will get your 52nd term. I should have called that a 52 if I was going to plug my 52 in. So when you plug that in, that comes out to, did you get 143? That should be your 52nd term. Questions on that? Okay, you have 9 minutes. Your homework is just a little bit of review stuff, but if you didn't do your 9-1 and 9-2 because you needed that little bit extra time, you kind of have a busy day, so get it done.